Welcome, everybody. We are just about ready to start review session number 4, which is going to be based off of F prime graphs and graphical analysis. If you look in the chat box on your menu, or just on your menu, you'll see some options for chat. We have a moderator tonight, Tony Record from Avon High School will be helping to moderate, and he'll be posting some comments, answering questions that you have, or just giving some other general information during the webinar. So if you look at the chat feature, you'll be able to ask him questions and also get replies. And so one of the things that he said was, if you're heading here, school besides Lebanon, Avon, or Franklin Central, if you could put that in the chat feature, just tell us what school you're at and possibly what state you're at if you're outside of Indy. Hopefully we have several of you here that can be joining us tonight from around Indiana, but also maybe even possibly outside of Indiana. Oops. So tonight's session, like I mentioned, is going to be focused on F prime graphs on the AP exam. I love this topic because of all of the FRQs. These are ones that I think that we could definitely rack up a ton of points very quickly and certainly beat the overall average by quite a bit. So we're going to jump right into it. If you have the handouts, you can go ahead and just write them handouts. If you don't have the handouts, you can do it on your own paper, but I would highly recommend that you don't just sit and get, or don't just sit here and watch, but that you'd also be doing the problems, thinking about how you would do these problems. Would you do the things that we're talking about tonight, or would you end up not knowing what to do, right? So there's a couple of things in here that hopefully you'll be able to pick up, add more points to your score, and then end up improving your overall AP score. So the first problem that we're going to end up looking at is from 2014. This is AB number 3. I believe it was also on the BC exam. The national average on this problem for all students around the country was 3.26. Once we go through this, I think you're going to realize there's literally no reason why you couldn't get all 9 points on this problem. This should easily be a question that any student, whether you've been really strong in calculus all year or whether you've had some difficulties, you can get 9 points. The key to getting all points on this is being very careful about how you start the problems, and then don't get confused between the pictures and what the questions are asking about. At the end of the handouts, if you have the handouts, the very last page of the handouts looks like this. And if you don't have the handouts, if you go talk to your teacher, we did share the handouts. And if your teacher wants to contact myself or Mr. Record, we can share the handouts with them so you can have this. But this is a pretty handy handout to use when you're doing these kind of F prime and functions defined by integral graphs. So I have this listed this way, where all the questions they ask you on the AP exam are kind of sitting here in the left-hand column. So they might be asking you for a relative maximum or a relative minimum. Of course, I just realized already there's a little typo here, right? This should say relative minimum here on this one. I'm going to go ahead and change that. I'll make sure that we change that for your teachers before we give them to you as well. And then we have increasing, decreasing, points of inflection, concave up, concave down, and then possibly absolute maximums or absolute minimums. And so if the question is asking about a function f, this is sort of what we're being asked about. Second column is sort of your starting point. What's the first step? How do you begin these problems? So I wrote possible entry points. And then the last column is going to be your explanation. But this last column also is going to be how you're going to find the answer. I think for me, the explanation or the reasoning is not just what I do after I find the answer, but this is what I do to help me find the answer. So if something is asking when f has a relative maximum, I typically will write down on my paper, well, I know the starting point is I have to figure out when f prime is 0 or undefined. And that doesn't make it a relative maximum, but it gives me a starting point. And then once I have those possible points, those critical points, then I look for places where that f prime value changes sign from positive to negative. If that happens, then I know it's a relative maximum. Relative minimum was very similar, except for the explanation or the reason is going to be because f prime changes sign from negative to positive. And so we're going to be using these sort of entry points and these reasons throughout the session tonight, right? Points of inflection, these are based off of the second derivative, right? So things like relative maximums, relative minimums, increasing and decreasing, all of those types of questions are going to be based off of the derivative, whether the derivative is positive or whether the derivative is negative. But then things like points of inflection, concave up and concave down, those are going to be based off of the second derivative. So a point of inflection is anywhere on the graph where the second derivative changes sign. And then a graph is going to be concave up if the second derivative is positive, and a graph is concave down if the second derivative is negative. So before we jump into the first question, I just want you to realize I'm going to be using this terminology. And if we use these explanations on the exam, we know that we are always going to be able to earn credit for those questions. I will tell you, though, that some teachers, many teachers, teach these questions a little bit differently, and that's okay. And so the way that I explain them, if you have been learning this sort of a different method, you're free to ask questions in the chat box to say, hey, this is how I learned it. Is this acceptable? And Tony will be able to respond to you whether that would be acceptable or not on the reading. Or he may even just offer up some additional ways that you could be writing these explanations. But I'm going to be using the ones that were given in that table. So yours might look a little bit different from mine. Don't worry too much about that. If you're unsure whether your explanation would count, ask the question or check the chat to see if Tony were to go ahead and provide that for us. So this is the first problem from 2014. We're going to hopefully get through 3 problems tonight, 2014, 2000. Different types of forms that you might have when you're given these f prime graph problems. So notice, first of all, what they gave us here in the picture is a graph of f, right? This is a graph of f. And it says the function f is defined on the closed interval -5 to 4, which we can see here in the picture. And the graph f consists of 3 line segments, which we can see, and it's shown in the figure above. And then they introduce this new function g. And it says let g be the function defined by g of x equals the integral from -3 to x of f of t dt. A couple things I want to point out. When we use letters like t and x on these integrals, we call this a dummy variable, meaning they're essentially taking on the exact same role. So don't ever get confused why one of them is an x and one of them is a t. When this says f of t dt, it's referring to this graph right here. And this x and this t are essentially, serving the same purpose, okay? So the difference of letters shouldn't really affect you. If you're writing an equation and you use the t instead of an x, generally speaking, we're not going to penalize you for that. It's not a spelling test. The only time you might be penalized is if those letters were used somewhere else in the problem, and all of a sudden you using it causes some confusion about what you're talking about, right? But in this case, we're not having any other formulas with x in them or any other formulas with t in them. So they're essentially going to be interchangeable for most of what we're doing. But this is the MO of the AP exam, and this is how they're going to get you. So remember, you want to break these questions down, and you want to follow a really solid plan. Because what I have noticed, and I'm sure what Tony will agree is, we see a lot of students who clearly know what they're doing on the AP exam, but they lose a ton of points on these problems because they're going too quickly. And you're going to make mistakes on the AP exam that you would never make on a normal day. That you might not have never made this mistake before, but you've also most likely not very often have sat down for a 3.5-hour exam with all the pressure that's on your shoulders and had to take a test like this. By the time you get to a question like this, you will have been testing for almost, if not 3 entire hours. And so you want to set yourself up to not make those mentally fatigued mistakes. And so the problem gives us a graph of F. And then look at the questions. All of the questions are about G. Find G of 3. When is, on part B, when is G increasing in concave down? If I jumped ahead to part C and D of this problem, they introduce a new function H, which is defined as G over 5x. And then on D, they introduce a new function P of x, which is defined by F of x squared minus x, right? So looking at this, most of these questions are referring to this graph of, or this equation of G, which we don't really have a picture of, right? And so you want to be really careful about looking at this graph and making assumptions, right? So we're going to be really careful about how we tackle this problem. So the first part, on part A, it says find G of 3. Well, notice G is defined by this integral here, right? And my recommendation is anytime you see a function defined by an integral, the first thing I would do is use the second fundamental theorem of calculus and differentiate both sides, right? G is the integral from -3 to x of f of t dt, then that means that g prime of x, if I differentiate the left-hand side, is going to be equal to the derivative of this integral, right? And by the second fundamental theorem, we know that when we're differentiating a definite integral, we can just substitute that variable in, and it becomes f of x. And in theory, we would have to multiply that by the derivative of what we just plugged in, right? So since we plugged x in, we're just multiplying by 1 because x's derivative is 1. But just be careful, because had that been a 2x on a problem, you still would have been a 2x, but then by the chain rule, you would have multiplied by 2. And a lot of students just get so used to plugging x in, they don't remember that there's actually a chain rule to that, right? So g prime is just going to be equal to f. And then I'm also going to recommend that we take another derivative. So g prime's derivative is g double prime, and that's going to be equal to f's derivative, which is f prime. This little step right here, what we're doing is we're connecting G and F together, and it's a really critical step to how we're going to approach these problems. So G prime is equal to F. Well, notice this was a graph of F, right? So I'm going to go ahead and put an equal sign there, and we just discussed that F is the same as G prime. So not only is this a graph of F, it's a graph of G prime. So anytime they're talking about G prime, I now realize they're talking about this graph. So I like to connect everything to G if possible, because all the questions are going to involve G. So part A says, let's find G of 3. Well, luckily for us, we have an equation for G, right? G of x is just the integral from -3 to x. So G of 3 is going to be the integral from -3 to 3, because that's what x was, of f of t dt. And so if I want to find G of 3, I have to integrate f. Well, this is a graph of f, right? So I want to integrate this graph from -3 to 3. Well, here's -3 here, and this is 3 here, and I need to integrate this graph. Well, the AP exam is going to make you integrate a lot of ways, and we discussed this, you know, on some of the earlier webinars. Tony, in one of the first sessions last week, worked on tables, and if you have a table of values, you can approximate an integral by doing a Riemann sum or a trapezoidal approximation. If we gave you an equation of f, then you could integrate it just by using the antiderivative and the fundamental theorem to plug in those values. But another way to integrate is through graphs, right? We don't have an equation, I don't have a table, but we can integrate. And so geometrically speaking, if we ever ask you for the integral of a function, we're asking you for the area between that function and the x-axis. And so the integral from -3 to 3 of f of t is just the signed area from -3 to 3. So we can see the first part of our graph is a triangle. And so the area of a triangle is 1/2 base times height. So we have 1/2. The base of this first triangle goes from -3 to 2. So that's going to be a base of 5. And then the height of this triangle is 1, 2, 3, 4. So it's going to be a height of 4. And then we also have to include this other little triangle here because we're going all the way to 3. But notice this triangle is below the x-axis. So when we find the area, we're actually going to have to make it a negative value. Anything when you're integrating below the x-axis should have a negative integral. So it's -1/2. The base of this triangle is still 1. And then the height of it is this little piece right here. And you can tell by the way the slope of this graph looks. Notice it starts at the point 2 and it ends when x is 4. And so at 4, -4, from 2 to 4, it went down 4 spaces. So if I went over one shot, it should have been a height of 2, right? We're going halfway. If I go halfway across, we're going to be halfway down. So the height of this is 2. Now, you might have in your class been taught to put a plus sign here and then make this to a -2 because technically we're going down for the height. Either one of those is going to be fine. The ultimate result is this value, the second part of this area should be a net of a negative area. So we get 1/2 5 times 4 minus 1/2 1 times 2. And because it's the FRQs, we are allowed to leave our answer just like this. There's no need to simplify. If you feel the urge to simplify, there's nothing wrong with that, but just beware if you do simplify and you keep going and you make any kind of arithmetic mistake, you're not going to earn this point. And so I always recommend on the FRQs, leave things as they are, right? And then guarantee that point. If you wanted to simplify this, you end up getting 10 minus 1, which is 9. So our final answer is going to be 9. So I'm going to move down to part B, and you're really going to see why I had that original sheet in the very beginning. So in part B, it says, okay, where is the graph of G both increasing and concave down? And this is where students can really lose points if you're not being careful, because what happens is your eyes want to keep looking up here at the graph, trying to answer questions by looking at this graph. And that's a very dangerous place to be, because the best way I think to guarantee not making any mistakes is I always say, answer these questions in isolation. And what I mean by that is interpret what these statements mean without looking above. Don't look at the equation if there is one. Don't look at the graph if there is one. Don't look at the table. Just look at what the question says. The question says, when is G increasing? Well, from our little handout here that we had at the end of this page, right, at the end of the document, a function, any function, I called it f here, but any function is increasing if its derivative is positive. So when we go back to this question and we want to know when is G increasing, well, G is going to be increasing if G's derivative, G prime, is positive. So we also know that G has to be concave down. So G is going to be concave down. Remember, concavity is based off of the second derivative. Notice I'm not mentioning f at all. I'm not trying to incorporate that graph right now, because that graph is a little bit dangerous, because you end up getting things mixed up if you start mixing the two things together. So G is concave down means that G's second derivative is negative. So what we're trying to do right now is say, okay, I have to figure out when G prime is positive. That would mean G is increasing. And then G double prime is negative, which means that D is concave down. And I want to figure out when both of those things are happening at the same time. When is G increasing and concave down? Well, now that I've written this sort of roadmap out, now I can actually go back and find those things. So the first thing I want to find is when G prime is positive, right? Well, this is a graph of G prime. The first thing we did was we labeled this graph G prime. And so if I want to know when G prime is positive, I want to know when this graph literally is above the x-axis, right? And so what we're looking at red are all the places where G prime is positive. But not only does G prime have to be positive, we also need to figure out when G double prime is negative. So think how I'm going to figure this out. I'm going to put this in black maybe. So G prime is positive in red. So I know my answer has to be up here somewhere. But on top of that, I need G double prime to be negative. Well, if you have a graph of G prime and you're trying to figure out something about G double prime, then we realize that G double prime is just the slope of this graph, right? If this is a graph of G prime, then G double prime is just the derivative of G prime. So I'm trying to figure out on this graph, when does G prime have a negative slope? If we want G double prime to be negative, I want G prime slope to be negative. And so we see a negative slope here. And we also see a negative slope here. And I'm going to stop right here because technically we do know there's a negative slope down here as well. But what we're looking for is the place where it's both of those things, where the graph of G prime is above the x-axis, but also where G double prime is negative, meaning G prime is decreasing. So we can see our two intervals. It's going to be from -5 to -3 here, and then again from 0 to 2. Whenever we're giving intervals, we're always trying to write these intervals in terms of the x intervals, right? And so we're going to have -5 to -3, and then we're going to have 0 to 2. Notice I used open intervals, and I use open intervals because the question told me to use open intervals. Now, it also wants us to give a reason for our answer. One of the reasons why I love this roadmap, that last kind of page that I showed you of all those translations, is this right here is literally our explanation. So I can say, I know for a fact that there's going to be, G is going to be increasing and concave down because G prime was positive and G double prime was negative. If you ever look at some of the scoring guides for the AP exams, they might have different wording. And in fact, your teachers might use different wording, and the other wording is fine. They could have said G prime is greater than 0. And they could have also said, instead of saying G double prime is negative, they could have said G prime is decreasing. That would have been acceptable as well. I like to keep mine simple by using this. And we're allowed to do this because in the very beginning, we made these connections. The first thing we did was we took the derivatives and we said G prime is F and G double prime is F prime. If we didn't make that connection right there, then we wouldn't have been allowed to use these explanations. And so it's really important that we have these proper explanations because of this connection right here. So let's move ahead and let's go on to part C. And I went ahead and recopied the graph here. And so in part C, we have some new function H, which the College Board likes to do to you, right? They'll introduce some stuff and they'll just throw in some new function just to see how you handle it. But it really is pretty easy. We have H of X equals G of X over 5X. And it wants us to find H prime of 3, so the derivative. So the first thing we're going to do is just take H's derivative. If it tells us H is this, and it wants H's derivative, we can do this. We see a fraction here, or a quotient, so we know we're going to have to do the quotient rule, right? So the quotient rule is going to be low D high, so 5X is low, and then D high is going to be G prime, right? If G is the top, then the derivative is G prime, minus high, which is G of X, times D low, which is 5. 5X's derivative is 5, all over the bottom squared. And when you do the bottom squared, make sure you put it in parentheses because you're not just squaring the X, you're squaring the entire denominator. So this is our derivative, and all it wants us to do is plug in 3. So to find H prime of 3, we're going to plug in 3 for everything. So we have 5 times 3, and then times G prime of 3 minus G of 3 times 5 all over, and the bottom we have this 5 times 3 squared. And so we talked a lot, in this webinar and in previous webinars about when is it okay to stop? When have you simplified enough? And the general rule is going to be on the free response questions, you can stop simplifying as soon as you could plug your answer into a calculator. Well, if you look at what we have, we couldn't plug this into a calculator because I couldn't find G of 3 on my calculator. If you just said to me, find G of 3 with no information, I couldn't plug that in. So we're looking for numerical values, things that you could type into a calculator. So we can't leave any functions. We can't leave like G of 3 or G prime of 3 in our answer. So we are going to have to plug numbers in for those two pieces. So we have 5 times 3, and then we want to find G prime of 3. And remember from above, this is a graph of F, but it's also a graph of G prime. So G prime of 3, I can literally just look on the graph and figure out what is the y coordinate right there. If it's a graph of G prime and you're asking about G prime, you're just trying to figure out the y coordinate. And we already discussed in the last part of this that we know the y coordinate here is just negative. It's halfway between 0 and -4. So G prime of 3 is -2. And then we still have to find G of 3. And that seems a little bit cumbersome, but don't forget that a lot of times on the AP exam, they'll ask you to find something in part A or B that seems kind of random at the time. Like, why'd they ask me to find G of 3? Like, why not G of 4 or G of 1 or something? They ask you to find that because they know you're going to need to use it later on. They do this a lot on those rate in, rate out problems. So tomorrow night we'll be doing rate in, rate out problems. It'll be a similar case. So when they're asking for a random value, don't just start from scratch. Realize you already found that. And so we found in part A that G of 3 was 9. And by the way, if you did not simplify part A, if you left it as this kind of big mess that I said you could leave it as, you could have written all of that in parentheses and put that in for G of 3. So even though you need G of 3 later on, you could have used the really long version of it as long as you put it in parentheses, because anytime you plug a value in, you should use parentheses just to kind of keep one quantity. And then the denominator is going to be 5 times 3 all squared. And now all of a sudden I have numbers, right? All these are numbers that I could type into my calculator. We could stop right here and be done. And on the free response, again, this late in the exam, I probably would recommend that you do stop here, right? I know it's hard because you spent literally 12 years of your life or 11 years of your life in school being told you had to simplify things. And you should know how to simplify because 45 questions on the exam are multiple choice. And those multiple choice questions are going to require you to simplify. But for the free response, that's the 6 questions, the times that we have this year that we're given the freedom to not simplify. If you do simplify this and you make a mistake, you're going to end up not earning that last point. In case you're curious, if you just have already simplified it, all of this turns into -1/3. But again, we could have stopped right here and been done with it. So moving on now to the last part, we have this new function. We had H in part C. Now we have this function P. P is equal to f of x squared minus x. Find the slope of the tangent line. When you're doing FRQs, look for those key words. A tangent line sounds so familiar, right? There's a lot of that on the AP exam. And it wants the slope. And we know that slope of a tangent line is equivalent to the derivative, right? When you take a derivative, you're finding the slope of the tangent line. So if I want to find the slope of the tangent line here, I'm going to start by taking the derivative. So p prime of x, and we have this kind of function notation here. These things look kind of bizarre at first, but you're going to find out they're the easiest you're ever going to see. Because whenever we differentiate something, we always start on the outside, right? The outside is f, and we take that derivative. So f's derivative is simply f prime, right? We notate it as f prime. And then we always leave the inside unchanged, right? So when we're taking something's derivative, we take the outside derivative first, leave the inside the same, and then by chain rule, then we multiply by the inside derivative. So x squared minus x, the derivative is 2x minus 1. And I want you to see how I left this, because I saw this probably no less than 50 to 100 times when I was grading exams in 2014, that students that left it like this. And if you wrote your answer like this, automatically you lost a point on this problem, because we want to multiply by all of this. And I would guess that the students who left it like this, that pretty much every single one of them knew they were multiplying by all of this, but they didn't realize that if you write it like this, you're technically only multiplying by 2x. By order of operations, this is just times 2x only. And so what we need to do is, when you do chain rule, put that chain in parentheses. Otherwise, you're going to lose an easy and free point that you shouldn't have lost. So this is the derivative. And then we want the derivative at -1. So once we've taken the derivative, we can now plug in -1. And so this is where you're going to be a little bit more careful, because you don't want to make any mistakes. If you plug -1 in here, and if you square -1, well, -1 squared is just 1, right? Anything squared is a positive number. And then it's minus x. Well, if x is -1, it just becomes minus and negative, which is actually just +1. And then we're going to have times. 2 times -1 is -2, and then -2 minus 1. And so if we simplify this, we have f prime of 2 times -3. -2 minus 1 is -3. We can't leave it like this, because again, we can't type that into a calculator. We have to actually find f prime of 2. But lo and behold, if we go back up here, this was the graph of f, right? So you got to pay really close attention to the letters that you're dealing with. This is a graph of f, and we're trying to find f prime. Well, if you have a graph of f, then f prime would certainly be the slope of the graph, the derivative of the graph, which is the slope. So we want to find, in this case, f prime at x equals 2. So if I scroll back up here, we can see this is that point when x is 2. And I want to find the slope right there. Well, if you want to find the slope right there, this is part of a linear function. So the slope everywhere is the same. So we can just find the slope anywhere on this line, and then that will be the slope right here as well. So if I start at the endpoints and find the slope, we're starting up here at 0, 4, and we're going from that point down 8 units. To start at 4 and get down to -4, you're going down 8 units, and you're going over 4 units. So our slope is just -8 over 4, which is just -2. So we end up getting -2 times -3, which is 6. So there we go. That's going to be the end of this particular problem. I want to show you the scoring guide, because I want you to see how easy it would have been to rack up just a lot of points in a really, really fast manner. So I'm going to jump over here to the scoring guidelines. This is the problem that we just did. In part A, we found g of 3, and that was 9. That was just 1 point, for knowing how to find that. And then in part B, we had 2 intervals, right? We had -5 to -3 and 0 to 2. If you had both of those intervals correct, you're going to get a point. And then the reason, like I said, there's a lot of ways you could have written that. You could have said because f is positive and decreasing, or you could have said what we had, or what I wrote down, which is that g prime is greater than 0 and g double prime is less than 0. That would have given us the reason point. And then in part C, we did the quotient rule, and notice just for doing the quotient rule correctly, they gave you 2 points for that. Just 2 points for finding the derivative, and then another point for plugging in 3 and evaluating these 2 values correctly. Notice this little line right here, when we had 15 times -2 minus 5 times 9 over 225, this would have been enough to earn the answer point. When it says the answer point, it just means as soon as you have numbers, you've got that point as long as you're correct. So we could have simplified or not simplified. As long as we had numbers, we get that answer point. And then finally on part D, notice again, because we had to use the chain rule, they gave us 2 whole points just for taking the derivative correctly. If you had forgot to put parentheses around this 2x minus 1, you'd have only gotten 1 of those 2 points. You would have lost an easy free point. And then finally, the last point is correctly evaluating this and getting a number that's equivalent to 6. I don't think any of those 9 points are beyond any of you right now. You know, if some of this is new to you or you're not comfortable with these, just go and get a bunch of these problems, right? Ask your teacher for a bunch of F prime graph problems. And if they don't have them email me or Mr. Record, and we'll send them a file of like 7 or 8 of these problems from previous AP exams, and just practice these like crazy, because you're not going to find an easier question to get 9 points on than something like this. And the beauty of this problem is that, like I said, the average score on this was only 3.26 points, right? So if you got 7 or 8 or 9 points on this, you're really crushing it, right? As you think about your AP scores, if you get the average score on something, that means you're kind of on track to earn a 3 on the AP exam. So if you got the average on everything, you're right around the 3. And if your goal is to get a 4 on the AP exam, then you have to pretty much beat the average score on the FRQs by 1 point. So if you had 1 point more than the average on all the problems, you're going to kind of pace for a 4. And if your goal is to get a 5 on the AP exam, you essentially have to beat the averages by about 2 points on every problem. And that's going to pace you for a 5. So imagine you got 8 points on this problem or 9 points on this problem. You're beating the average by 5 or 6 points. And that's going to really build you a nice cushion up for those harder questions where maybe you struggled a little bit. So let's try another one here. This is from 2017, and this one's a little bit different. This is why I wanted to show it to you, because the first one we did, it gave us a graph of F, and it started talking about this equation of G, which was the integral of F. Well, this doesn't do that. There's no integrals here, and it's not even mentioning any other equation G, but it's telling us it's a graph of F prime. So every graph you get essentially is going to be the derivative of something, right? On the last graph, the graph we had was F, which was the derivative of G. And then in this problem, we have a graph of F prime, which is just the derivative of F, right? And then it also mentions here the step, which is pretty important, that F of -2 equals 7. And so in part A, this is very similar to what we found before. It says find F of -6 and F of 5. Well, this is the fundamental theorem. Notice the AP exam does this in a lot of different ways. And as soon as you recognize that all these problems are essentially the same thing, it makes them all kind of make sense. That if you're doing particle motion and you want to find the final position, or if you're taking a pizza out of an oven and you want to figure out the temperature, or there's people coming in and out of an amusement park and you want to know how many people there are at a certain time, or if you have a graph of F prime and you want to find F of -6, all of those questions, all 4 of those things that I mentioned are actually the same question disguised as different problems. And so once you realize these are all the same thing, it makes your life really easy, because the AP exam loves to give you derivatives. The only thing they told us really was a graph of F prime, the derivative or rate. And then they ask you questions about F, not F prime, but about F. So anytime on the exam, they're asking you for an amount or a value of something, they typically have given you the derivative of that. And so the way we solve this is by the fundamental theorem, which says if you want to know a final amount of something, in this case, F of -6, then we have a starting value. Well, notice the starting value here says F of -2 is 7. This is my starting value. Your starting value won't always be at 0, and it won't always be the first number on the graph. It's just some value that the AP exam is going to give you. So F of -6 is going to be equal to the value that they have given you plus the integral from where you started. So you started at -2, that has to go on the bottom, to what you want to know, which was -6, and what you're integrating is the derivative or the rate. So any value that you want to know is starting value plus the integral from where you began to where you want to end of the derivative. This works for particle motion. It works for pizzas in an oven. It works for just about any other situation that you can imagine. So now all we have to do is calculate this. Well, first of all, F of -2 we know is 7. So I'm going to put a 7 in there. I like to put F of -2 first before I plug in 7, because if I call this 7 right off the bat, sometimes when you're tired, mentally exhausted, you end up putting a 7 down here instead of a -2. So I'm kind of doing this to protect myself, and then I can plug in 7. And then notice, we don't really want our bounds to be in this order. We always want the lower bound on bottom. It's kind of a proper integral. And so if they're ever in the wrong order, we can flip those two bounds around, right? We can go ahead and make it -6 to -2. But when you flip the bounds, it makes the sign the opposite. So now it becomes subtraction instead of addition. So now we have 7 minus the integral from -2, or from -6 to -2 of this graph. So this is kind of like the problem. We're trying to find the integral of f prime, and the integral of f prime is simply the area between the graph and the x-axis. So from -6 to -2 is just this region right here, which is a triangle, minus 1/2 base times height, and the base here is 4, and the height is 2. And so our answer here, we can just leave it like that. Right? The f of -6 is just 7 minus 1/2 times 4 times 2. You're welcome to leave it like this. If you want to simplify it, you end up getting 3. And then to find other value, f of 5, that's the other question. It's the exact same setup. It's going to be our starting value, which is -2 again, plus the integral from -2 to 5, where we're starting to where we're trying to get to, of f prime of x dx. And again, f prime of 2 we know is 7. That was given to us. And now I don't have to flip these limits because they're in the proper order. But now I want to go from -2 to 5. So I'm going to go and I'm going to change the color of this just so that way we can not get confused with the last example. From -2 to 5 would be all of this all the way to here, right? So we have a semicircle or a half a circle that's below the x-axis, and then we have a triangle that's above the x-axis. And so if I'm trying to find the total integral, I'm going to have to realize that the semicircle, because it's below the x-axis, that's going to be a negative answer, right? And generally speaking, a semicircle, the area is 1/2 pi r squared, because it's half a circle. But I'm going to make this a -1/2. Obviously, you could have made this just a subtraction sign, right? Because it's minus. But it's -1/2 pi r squared. And r in this case was what? 2. So it's -1/2 pi times 2 squared. And then we have this little triangle at the end. And the area of a triangle is a positive because it's above the x-axis. 1/2 base times height. So we're going from here to here. The base is 3, which we can see on the graph. And the height is 2. This answer right here would earn all of the points. If I had had a chance to write this over again, I probably would have made that just a -1/2, right? Just -1/2 pi times r squared, and then add a positive 1/2, 3 times 2. This is fully simplified for the AP exam. You don't have to do anything with that. But again, if you want to simplify that more, you can. And if you simplify this, you're going to end up getting, what is that? That's going to be 10, I believe, minus 2 pi. So the way that we score problem is if we go to the scoring guides, that part A in this problem is actually worth 3 points instead of just 2. And here's the scoring guide. Notice if you remember to use the condition to add that 7 to your answer, that was worth a point. Then if you correctly found f of -6, we got that answer, that was worth a point. And then f of 5 was another point. So that was 3 points that I don't think were very difficult to earn, but you just don't want to go fast, right? If you go fast, you're going to end up making errors with your negative signs. You're going to forget that things below the x-axis are going to have a negative integral. You're going to make little mistakes. You're not going to remember to flip the limits. So take your time, do these steps, and you know you're going to get good answers, right? So let's go to part B. On what intervals is f increasing? So again, I don't like to look at the graph and answer the problems. I like to look at the question and say, what does it mean for f to be increasing? So if I write down or I translate what that means using our sheet or handout, f increasing means that f prime, f's derivative, must have been positive. The reason why I like to write that down is because now when I look at the graph, I know exactly what I'm looking for. I'm looking for a spot where f prime is positive. Well, this is a graph of f prime, right? I mean, we're looking at f prime right now. So if I want to know when f prime is positive, I'm just looking for when this graph itself is above the x-axis, right? I'm not looking at the slope of this graph. I want to find out when f prime is positive, is f prime. So I'm looking for all of these values above the x-axis. So we can see it's from -6 to -2. The graph is above the x-axis. And then also from 2 to the end, which is at 5, graph is above the x-axis. So our answer in this case is going to be from -6 to -2 and from 2 to 5. Now, if you use closed brackets instead of parentheses, I'll be honest with you, on the exam, 99% of the time, we're not going to count off whether something is open or closed. And the reason for it might be surprising to you. The reason is because we have a hard time writing, and it's a little bit difficult to tell the difference between a parenthesis and a bracket. So, 99 times out of 100, we just don't really pay attention to which one it is because of that exact reason. We don't want this to become a handwriting test. So I'm going to use open parentheses. But if you had used a bracket around the -6, it wouldn't have counted off for anything. If you had bracket counted off. And then we have to have a justification. The reason why I love that little chart is because that thing that we wrote in the beginning to help us find our answer, that is the justification. You don't have to use any other information to tell us how we knew that. Well, we knew it because f prime is greater than 0. That simple statement right there is all that you needed. And so this is also worth 2 points. 1 point, they're kind of tied together, but essentially you can think of it almost as 1 point for the answers and then 1 point for the reason. If we jump ahead to part C, now we get this question of an absolute minimum of f, right? And this is where, again, it really helps to kind of think about that roadmap that we had on those sheets. To find the absolute minimum of something, the first step is to find the critical value. We have to think about when f prime is 0, or possibly even when it's undefined. And then once we find those values, because we're finding an absolute minimum, we're not going to do a sign chart. What we're going to do is make a table of values and plug things into the original problem. The first step is to figure out, when does f prime equal 0? Well, this is a graph of f prime, so I want to know literally when this graph crosses the x-axis, and we see that happens here, here, and then kind of at the end point here. And so we know that f prime is 0 at -2, 2, and 5. Now, what we see a lot of is students know that critical points also happen when f prime is defined. And so what they end up looking at is, well, there's a corner here. Isn't that undefined? But you have to be careful, because if there's a corner point on a graph, that means that the derivative of this graph is undefined, right? So a corner doesn't mean the graph is undefined. A corner means that the derivative of this graph is undefined. Well, this is already a graph of f prime. So right here, the derivative of f prime, which is f double prime, that is undefined right there. So we're looking for when f prime is undefined. F prime is defined everywhere on this graph. I know that f prime is defined everywhere because I can literally see it. If there was a hole somewhere or a missing piece, then f prime would not be defined. So my only critical values are -2, 2, and 5. And then what we do with those values is we make a table, not a sign chart, and we plug them into whatever it is we're trying to find the minimum or maximum of. And for absolute minimums and maximums, we also have to include the endpoints, right? So we're going to have -6 is one endpoint. We have a negative and a 2 as our critical values, as well as 5, which happens to be the other endpoint. So these are all the values that we want to find. And so now we have to figure out, well, what is f of -6? What is of -2? What is f of 2? And what is f of 5? Well, remember I talked about in the last example how a lot of times they'll ask you kind of what seems like random questions in part A, but all of a sudden start becoming important later on. Well, in part A, they asked us to find f of -6, and f of 5. And now we're going to see them here in the table. So f of -6 we said was 3, and f of 5 we came up with as 10 minus 2 pi. And then the problem itself told us f of -2. F of -2 is 7. So the only thing we're missing now is f of 2. So we're going to have to do a little bit of work, and we're going to have to find f of 2, but we're going to find it the same way that we found the other ones. F of 2 is my starting point, plus the integral from -2 to 2 in this case of f prime of x dx. And f prime of, or f of -2 we said was -7. And then if we're integrating from -2 to 2, that's just this semicircle below here, right? So we talk about, since this is below the x-axis, we're going to have to make it negative or subtraction. And it's a half a circle, so it's 1/2 pi r squared. And the radius is still 2. So we end up getting 7 minus 1/2 times pi times 4. What is that? 7 minus 2 pi. So this is going to become 7 minus 2 pi. So this is our table of values, and we're trying to answer the question by finding the absolute minimum, right? Well, we're looking for the smallest value. Well, clearly 7 is bigger than 3, but then we have these other values that we're not necessarily as comfortable with, like how do you know which one's the biggest or smallest? Well, we're going to kind of ballpark it because this is a non-calculator question. And so if we think about 2 pi, right? Pi is about 3. It's a little bit more than 3, but for our mental purposes, we're going to kind of make it 3. So 7 minus 2 times 3 is like 7 minus 6. This is about 1. And then here, 10 minus 2 pi, well, again, if pi is about 3, it's like 10 minus 6, and 10 minus 6 is about 4. So we have answers of 3, 7, about 1, and a 4. So the minimum or the lowest is going to be this one right here. And whenever I see absolute minimums or maximums, I love to write the answers like this. The minimum, answer the question, the minimum equals whatever answer you came up with, 7 minus 2 pi. And I always say at x equals whatever the x coordinate is. The reason why I like to write my answers like this is because sometimes they ask you in the problem for the minimum value. Well, minimum value means the y coordinate. It's the 7 minus 2 pi. But sometimes they ask you for the x coordinate. Find the value of x where it has a minimum, in which case it's just asking for the 2. And it's possible it could be asking you for both. But if you write it like this, it doesn't matter what it's asking you, you've answered the question. So if the minimum equals whatever the answer is, the y coordinate at x equals the x coordinate, you know you're going to get the point no matter what question they ask you. It answers all the questions they might ask you and it identifies each one, and you're guaranteed to get that point. So looking at the scoring guide for that part right there, just looking at part C, it's only worth 2 points. 1 point for realizing that 2 was important, that 2 was in your table. That was the first point. So you would know that by setting f prime equal to 0. And then you're also going to get 1 point for the justification. When they ask you for justifications on absolute minimums or absolute maximums, the justification is your table. You don't have to write an explanation. You don't have to write any reasoning. If you show your work like we did and you show your table, that's what they mean by justifying. That's called the Canada's test for extrema. And then now the last part is just part D. And it says, find f double prime of -5 and find f double prime of 3. Find the value or explain why it does not exist. So looking at the graph, and the question that we're asking about is f double prime. The question is asking, when is f double prime, or what is f double prime of -5 and what is f double prime of 3? So in these problems, if you're given a graph of f prime and they're asking about f double prime, they're asking about the derivative, right, of this graph, or the slope of this graph. So the first question is, what is the slope when x is -5? Well, this is -5 right here. And we saw another question kind of like this on the previous example, right? And it wants to find the slope right here. Well, when it asks you for the slope at a point on a line, the simplest way to find that is just to find the slope of the endpoints. You know, a line will have the same slope no matter where you are. Let's just find the slope between -6.2 and -2.0. There's a couple ways that you could do that. You can actually work out with the slope formula, or you can just look at it and kind of tell with your eyes that it's going to go down 2 and over 4, right? You can see it goes down 2 over 4. So the slope there, rise over run, is just going to be -2 force, or if you wanted to, you can call that -1/2. And then the other one it wants us to find is f double prime of 3, the derivative or the slope at 3. And that's this point right here. And we kind of mentioned that already, that the derivative of this graph, or the slope of this graph, does not exist right here at 3. If you're trying to find the slope or the derivative of a graph, there can't be any corners or sharp turns. And so this right here would not exist. The second derivative would not exist. And so we're going to say f double prime of 3 does not exist, or you could say it's undefined. Is fine as well. And it wants us to give a reason. And there's some technical reasons we can use with limit notation and definition of a derivative. But in this case, they gave us a graph, right? So if they gave us a graph of something, we could give an explanation based on the graph. And so we know that this is no derivative here because there's simply a sharp turn, right? If you have a turn or there's a corner on a graph, we know it's not differentiable. So I'm just going to say here, it does not exist because there is a sharp turn on f prime of x, right? The graph that we were looking at was f prime. So f prime has a sharp turn at x equals 3. And if you look at the scoring guides for this problem, they're not going to use this kind of notation. They're going to use a lot of limit notation, and I'll leave that for your teachers. If you're doing an algebraic problem with equations and not a graph, the AP exam might expect you to use an equation or a limit definition, but that's a pretty minor point. If it's a graph, which they've tended to be in recent years, this would be a fine explanation. So as we wrap up here, I want to show you the scoring guide for that last part as well. So in part D, we see that it's worth 2 points. 1 point for finding the second derivative at -5, which was -1/2, and then a point for finding the second derivative when x equals 3, which we said does not exist, with the explanation. So that's 2 more points. So they gave us a total of 9 points. On this problem, you know, the first problem we set a pretty low average. This one didn't really fare much better. The average on this problem was only 3.63. So think back about this. How many points do you think you would have gotten on your own? But also, as we went through it, how many points do you think you were capable of, right? I'm hoping that many of you either feel really confident about these, thinking you should be getting, you know, 7, 8, 9 points on this problem, or you feel like I'm not quite there yet. If I practicing and doing some of these repetitive problems, that I could get myself up to a 7, 8, or 9. So that's kind of what your task is between now and next Tuesday, is get as many practice problems as you can, as many FRQs as you can, practice and then scoring, and really drill these in, because one of the things that's become pretty consistent on the AP exam is a graph of f prime, or the graph of, you know, f and g is the arrow. Is a kind of the same problem designed asked in different ways. So they're really problems that you can get a lot of points on, and you can really beat the spread if you practice them. So I spent some time doing that. Thank you guys for jumping on tonight. We went through a lot. Make sure if you don't have the handouts, get a copy of them, because I really want you to keep this last page for yourself. That way you can kind of a quick reference sheet as you're planning these things out. So it'll be really helpful. I'll stay on if there's any questions about anything that we did, or if you have loose questions in general, feel free to type them in the chat. I talked to some of my students and some of Mr. Rector's students, Mr. Rector, that sometimes students are a little bit hesitant to ask questions because they don't know anybody. I don't want Feel free to ask any questions if you have them. And then, Tony, I'm going to see if you could possibly get a screenshot of the names for Mr. Strassel. If you have any questions, feel free to ask them now. If you're done and you feel confident, you're good to log off. But Mr. Recker and I will stay on to answer any questions that you have.